Hi, this is Mr. Ward, and I've been noticing a number of people bogged down in level 7A, so I'm going to do a video on simply how do I do this. And so I'm going to pick a few problems from this sheet, which is one of the sheets that is listed here. It's the LAVC worksheet with a key, okay, and let me get to it. There it is. And I'm going to go ahead and work some problems. So the first one, 3k squared minus 10k plus 7. Now, there are a variety of methods. I'm just going to use one method so I don't complicate it too much. And I'm going to take the 7 and the 3 and multiply them up here. So that equals 21. And I need two factors of 21 that add up to negative 10. Okay, now because I've got a positive number and a negative number that I'm adding up to, then I'm going to be using the two negative factors of 21. So minus something and minus something. Now you may be able to see fairly quickly that a couple of factors that would work would be negative 7 and negative 3. Okay, so what I can do at this point is I can break this up. I can rewrite this equation and apply a tool called factor by grouping. And the whole reason I got the negative 7 and the negative 3 was to figure out what I could break negative 10k into. So I'm going to break it up into negative 7k and negative 3k. If you put those together, you get negative 10k. And then I'm adding 7, of course. So this is the same as what I've got here. 3k squared minus 7k minus 3k plus 7. And the first thing I'm going to do is I'm going to group these here. And this is a tool you can use with factorable stuff. I'll put a plus here. You'll probably notice I kept the negative in there. And then I'm going to look for a GCF. So GCF of both for each group. So that should be a G. So when I look at 3k squared and negative 7k, there's nothing I'm going to be able to pull out of 3 and 7 other than 1. So, but I can pull out something from the k squared and the k. That's k to the first, and k to the second is k times k. So I can pull a k out. So I pull a k out, and I'm left with just 3k, because 3k squared divided by k is just 3k. And then 7k divided by k is just 7. So now I've got that as a factor. Now I'm hoping that I'll end up with a 3k minus 7. And I notice I've got a negative 3k plus 7. If I were to change the signs of both of those, I'd be in good shape. So what I'm going to do is I'm going to factor a negative 1 out of there. And I'll end up with 3k, the opposite of negative 3k. And the opposite of plus 7, so minus 7. Okay, so now I've got k and a minus 1, and I've got the same factor here and here. So that's going to factor as 3k. I'm using the distributive property. 3k minus 7 times k minus 1. Okay, and where did I get the k minus 1? Well, 3k minus 7. And so k and negative 1 share the same factor being this thing called 3k minus 7. So because they both share 3k minus 7, I factored 3k minus 7 away from both of them, and it left me with just k minus 1. And these are the factors of this quadratic. Okay, I'm going to pause and erase some stuff. Okay, now I'm going to take care of a couple more complicated ones. So I've got 6x squared plus 41x plus 70. Now I'm not going to make the big x because it takes up a lot of space, but I know I'm going to be getting 6 times 70. So 6 times 70, okay, which happens to be 420. Now, 420 is probably outside of your typical multiplication tables that you would know factors from. So I'm going to use another tool. We want to get 41. Our goal is 41. So we need two factors of 420 that add up to 41. So a good thing to do is just break 6 and 70 into their factors, because their factors are going to be all the factors that you put together in this. So I'm going to have 2 times 3, and then I'm going to have 70 is 7 times 2 times 5. And what I want to do is mix and match and rearrange these factors so I get two products that add up to 41. Now I immediately notice 3 times 7 gets me a 21, and that makes me suspicious that maybe that will work. So let's see, 3 times 7 is 21, and then 2 times 5 times 2, well, that's 4 times 5, that's 20. So now I've got, well, that should work. I've got 20 and 21. So 20 and 21. 20 plus 21 does add up to 41. So I would just reorganize this. I'll end up with 6x squared. And I'll pause while I write it all out. So I've written this out. I've taken the 6x squared, and I've taken the 70. I've left them as is. But I've taken the 41x and broken it up into 20x and 21x. Now I'm going to group it like this. I could have swapped the 20x and the 21x, by the way, it'd still work. So I'm going to group it like that. And I'm going to be looking for a GCF, a greatest common factor, for 6x squared and 20x. So I definitely can get an x out of there, and I definitely can get a 2. So 2x seems like it's probably the largest common factor between these. If I divide this by 2x, I get 3x, because 3x times 2x is 6x squared. If I divide 20x by 2x, I get just 10. 20 divided by 2 is 10, and x divided by x is 1. So I'm left with 3x plus 10. And then over here, I look at these two. I'm not getting any x's out, but 21 and 70 definitely share a 7. So plus 7 at this point. And 21x divided by 7 is 3x. And 70 divided by 7 is 10. And as you see, we've got the same factor shared by 2x and 7. So I can factor that out and then put 2x plus 7 together. And I'll end up with 3x plus 10. Amazing handwriting with this online tool, isn't it? So 3x plus 10, the shared factor. And then because it was shared by 2x and plus 7, I can put 2x plus 7 together as a sum as well. And these are the factors of 6x squared plus 41x plus 70. I'm now going to pause to erase some stuff. All right, we're going to try another one here. Let's see if I can find one with a negative in the middle. So this is, actually, you know what? I want one. What I want is one with a negative at the end. But let's go over here. We'll do this one here. 10n squared minus 21n minus 49. I'll scroll that up a little bit so it's at the top of the screen. And we're going to use the same old trick. Instead of drawing the x, I'm just going to take 10 and negative 49. So that's the things that I'm making a product out of. 10 times negative 49. And that, of course, makes negative 490. Okay. All right, so that's negative 490, and I apologize for writing on top of stuff there. My goal is to get two products out of this. I can split the negative 490 into two factors, I should say, that add up to negative 21. So I'm going to have negative 21 as my goal. So what I'm going to do is I'm going to do the same thing. I'm going to break 10 and negative 49 into their factors. So 2 times 5 times 7 times 7, and then there's going to be a free-floating -1. Now I'm going to account for that -1 by just declaring that one of my factors is negative and the other one is positive. Okay, so now I don't have to worry about that, and all I have to worry about is 2, 5, 7, and 7. Well, 21 jumps out at me as a number that is a multiple of 7, and I have these two 7s, so maybe I've got a 5 times 7 and a 2 times 7 involved. So let's test that out. Because I've got opposites, what I'm looking for is not two numbers that add up to -21 in a way, but I'm looking for two numbers. And once I have accounted for this negative, I'm looking for two numbers that are 21 apart from each other. So 2 times 7 is 14. So I've got 14. And I've also got 5 times 7, which is 35. And those, in fact, are 21 apart. So if I were to put these together, I need to figure out which one is negative and which one is positive. Since my sum is negative, the bigger number has to be negative. So -35. And that's going to be positive 14. Okay, now my whole goal was to find a way to break up this -21. So this is the question I'm dealing with, this -21n. And so I'm going to put an n here and an n here. And those are two pieces of -21n that would add up to -21n. I'm going to have 10n squared over here. And I'm going to have -49 over here. And then I'll group it. So I've put this is just the same equation I had before, and I group it. And I'm going to find greatest common factors in each group. In this group, I can pull an n out, of course, and 10 and -35 share a factor of 5. So I can pull a 5n out. And that becomes 5 out of 10 is 2, and n out of n squared becomes n. 5 out of -35 is -7, and n divided by n is 1. Now I'm going to look over here and see if I can get the same factor. So I look at 14n and -49. I can't get any n's out, but I can get, well, those are both multiples of 7, so I definitely can get a 7 out. So plus 7. And when I do that, I'm left with 2n. 14n divided by 7 is 2n. And -49 divided by 7 is -7. And look at that. We've got the same factor here and here. And that means that we can pull that out from 5n and 7. And we have 2n minus 7. And since 5n and 7 shared that factor, I can group them, put them together as 5n plus 7. And we have factored this thing. So 2n minus 7 times 5n plus 7 are the factors. I hope that that has given you a little bit more to work with, and I'm going to go ahead and stop at this point.